good afternoon to my fellow speakers and the audience. I'd like to actually take this opportunity to thank the organizer for hosting this important session on grid digitalization. Today, we have 4 distinguished speakers with extensive experiences in the industry. First, to introduce myself, I am Gary Ang from Singapore Power. I'm currently heading the Smart Grid and Operational Digitalization branch. Our fellow panelists include Eric Yoss. He is a partner for advisory business, power and utilities in Ernst & Young. Martin Haas, he is the Asia Pacific Energy segment lead in Nokia. Jen Enresh is the project management lead for Global Transmission Asia in Black & Veatch. And Nugroho Prananto Utomo is a senior consultant with DNV. So climate change is real and is affecting the world. Just looking at 2021, this year, the winter storm in Texas in February has actually crippled the entire power grid in Texas. So the extreme weather, the extreme heat wave in US and Canada, at the beginning of this month, in July, melting power lines, causing wildfires, and also hundreds of lives lost due to the extreme heat, which is almost 50 degrees Celsius. And most recently, the devastating flood in Germany, Belgium, and China, killing hundreds of lives. So climate change is the biggest threat to mankind, and combating it requires action and also commitment. In 2015, Paris Agreement, over 190 countries have solidified their support to limit global warming well below 2 degrees Celsius, preferably at 1.5 degrees Celsius compared to the pre-industrial levels. In Singapore, we are aiming for peak emission at 65 million tons CO2 equivalent around 2030. We want to halve that by 2050 and reaching our net zero emission target as soon as viable in the second half of the century. Our objectives are clear and it can be met by decarbonization. So obsoleting carbon-intensive generators and moving towards carbon-friendly renewables. Renewable deployment can actually be centralized or decentralized in this case. For instance, solar PV. It can be centrally and collectively deployed as a solar farm, or it can be decentralized and distributed way of deployment. So to reduce carbon footprint, we'll replace internal combustion engine vehicle with electric vehicle. So this certainly will increase the demand for power and the need for further electrification. So actually all these factors are affecting our grid in terms of the system dynamics, in terms of stability and control. So in the past, power flow is unidirectional from generation all the way to consumption. But for now, we have bidirectional power flow, and this bidirectional phenomenon is caused by decentralized and distributed energy sources connected to the grid. To uphold network reliability is imperative. So digitalization actually provides us the solution to mitigate all these system constraints. So with that, I'll start off with this first presentation from our first speaker, Eric Yoss. So just a brief introduction of Eric. So Eric leads the EY Advisory Power and Utilities practice for ASEAN, working closely with EY Global Industry team to drive industry strategy, thought leadership, and power and utility solution. He has over 20 years of experience in unbundling, deregulation, and transformation of major European utilities companies. His expertise covers supporting utility clients in defining their strategy, redesigning their organization processes and market model, as well as implementing new information systems. Among his experience include developing growth agenda and portfolio diversification, development of asset management and smart grid capabilities for transmission as well as distribution utilities companies across Europe and Asia Pacific. So his topic for the day is energy transition, a customer-led and technology-enabled transformation. So over to you, Eric.
Thank you, Gary, and good afternoon, everyone. Let me share the screen. Yeah. So thank you, Gary. And again, good afternoon, everyone. So today's topic is about obviously energy transition. Gary has been introducing obviously the importance of climate change and all the discussion that we're having. And actually what we're seeing today is what we call in EY, the birth of a new energy system. I think there's no need to re-explain the pressure that Paris Agreement has put on the different company, the importance of all the ESG, environmental, societal, and governance topic for all, I would say, the company, the investors, and the customer. But today, when you see the sector which is in transformation, there's different forces coming into play. And it goes from customer to market reform to competition, obviously the changing energy mix and new technology. But there's one that I would like to focus a little bit more on, which is first of all, the empowerment customer and why we are saying that this transformation is actually consumer-led and customer-led. Over the last 100 years, utility have been able to generate, transport, distribute, and sell energy at a rate which was very much linked to the growth rate of our economy. And utility were building plants, which were coal plants, gas plants, nuclear plants, and other, without actually having to justify how energy was generated. Today, what you see with the Paris Agreement, with the climate change and all those ESG discussion topic is that customers are actually asking the energy industry to transform and to generate green energy. So it's not only coming from the industry itself, it's really coming from, I would say, the customer, the consumer, large corporations which are asking to get green energy in their data center, into the building, into their transportation. So more and more, the consciousness and the importance of becoming green is being there and is actually requested by the consumer and the customer. On the bottom here, when you see new technology, we say it's technology enabled. You can see that actually over the last, I would say, 10 years, the cost of technology has dropped fundamentally. When you look at, I would say, solar and battery, I think over the last 10 years, the price has probably dropped with 80%. If you look also to all the technology, which are digital technology, being AI, analytics, digital twins, robotics, all those technology have not only dropped in price, but also are much more accessible. They're accessible because there's much more skills on the market, because there's much more technology supporting those, and because obviously data and data processing is no more constrained as it used to be a few years back. Which means that when you take those two, customer actually asking also for a green energy and transition. When you take actually technology which is becoming more affordable, you can see there's an acceleration. And there's no doubt that all the changes that we see are going to accelerate and are coming closer and closer. So if we've done a short study on what we call electric vehicle parity, which means when is electric vehicle going to be at parity in terms of performance of cost with internal combustion engine, we see that actually it will be the same price around 25, 28. If you look at energy parity, so actually producing, storing, and consuming your own energy versus buying from the utility, we see that actually the parity will come in Australia and Europe around 21, 22. Basically, Australia is already at the parity cost. And the rest of the world and most of the country will probably encounter that date by the end of the decade. So we are probably between now and 10 years' time at a point where not only electric vehicle in the context of electrification, but also green energy and parity of people being able to produce and store and consume themselves is going to happen between now, 5 years, and 10 years' time. We could generate, transport, distribute, and sell. And the world has been changing now, and we see it's accelerating. Now, when we say embracing those technology, it's even more important as we see that there's more and more competition entering the energy sector. So when we talk about competition, we're not talking about those other utility competing, but we're talking actually automotive industry, which is entering the sector at a very high speed. We talk about oil and gas, which is also entering and making more and more acquisition in the battery world, in the flexibility market, and also in renewable. You can see also all those tech companies which are offering more and more flexibility solutions. So when we say that utility needs to embrace technology if they want to remain relevant, is not only to be relevant in terms of keeping the grid smarter and being able to support the energy transition, but it's also to compete against new entrants. And you can see here on this graph that actually when we talk about technology, there's quite a lot of those. It's not only about artificial intelligence with analytics and robotics, it's also about digital twins. It's also about all the Internet of Things requiring IoT network and cybersecurity. It's also about blockchain, liquid application. So not only utility needs to embrace those new technology, but also they will need to change the way they work in terms of creating ecosystem and partnership. So today we're just going to focus on probably a bit more on two, which is advanced analytics and digital twin, just to give you a sense of what does that mean for utility and what does that mean for network companies. So when we look at the journey that network company will have to do, they're going to evolve to what we call a network company, which is really about managing a network, to actually a system operator, which is really about managing a system and being able to integrate all those different sources of energy, all those different components or part of the electrification. So being not only your EV, but your battery storage, your new renewable, being solar for residential, solar for B2B or large scale solar. So actually the network company are going to become what we call a system operator. To become a system operator, and it's not only about actually connecting energy sources, it's not only about fortifying and making sure that your network is capable of managing those flow of electricity, but it's also actually about controlling. And most of the utility are probably now, I would say, in the controlling step. Some of them are at the beginning, some are at the end, but most of the utility are actually in the controlling. They've already been ensuring that you can connect not only consumer, but also renewable. They not only have done the fortify, they're in the control, which is starting to actually manage and create some flexibility. The next step of this is steering, where you start creating more what we call discrete flexibility platform, where you start managing those different flow and trying to ensure that despite the fact that there will be reverse flow, you can still manage and support your network. And the end stage is actually what we call integrate, is becoming a real energy system integrator, meaning that whatever happens, whatever connection people want to make, whatever renewables comes on your network, whatever consumption is happening on the demand side, the utility and the system operator is able to integrate those and manage those at a high level of reliability and obviously affordability. To support this, you can imagine that a lot of your current system, being your ADMS, your enterprise asset management, etc., will need to be enhanced. And when we talk about enhancing and augmenting, analytics is actually one of the very important ones. And when we talk about analytics, it's also about AI being actually a more evolved form of analytics, where you can see that analytics will be helping in terms of revealing insights. It's going to augment all what your system are offering in terms of data, combined also with smart devices, IoT devices, and smart meter. It's also going to help optimize performance. And you can see here some example about predictive maintenance, about outage and constraint management, about storage deployment, about voltage optimization of VVO. So a lot of actually revealing insight, helping to make decision and optimizing performance. Also enhancing customer experience. I was saying at the beginning of the presentation, it's a customer-led transformation, which means that customer will be still at the center of this energy ecosystem. We haven't put any example, but obviously you can imagine that customer experience will remain very important. If tomorrow we want to go to kind of demand response, managing your energy efficiency, obviously the customer experience and the customer at the center will be a very important component. Supporting trust is also an important component of the analytics, and you can see here theft management is also about ensuring the reliability of your system. And obviously intelligent automation, where you will see more and more processes being automated, being augmented based on the intelligence and the insights that you receive based on your data. So analytics is a very important component to help go from, I would say, this network operator to this system operator. Now, obviously, people would like to go one step further and being able to predict the future. And more, we're talking now about the digital twin. So digital twin is what we call a data-informed digital replica. We're trying to replicate the network to be able to digitally simulate, forecast, and make a number of scenarios. So typically, people are doing digital twins in the network company for, I would say, two main big purposes. You have digital twins around assets. So how can we better manage our assets? And digital twins in terms of system. How can I simulate my system and how can I see and predict how the integration of renewable, how the integration of EV, and the combination of battery and flexibility can actually operate. And you can see that basically those applications are often around predictive asset maintenance, about how can I do my better planning of my network, how can I do network collaboration and simulation, how can I better manage my distributed DER and distributed energy resources, and obviously workflow optimization. So a lot about creating twins that allows you not only to better manage your asset, but also better manage your system. And there's one case that I wanted to share with you around Enel. So Enel is an Italian utility who has been launching what they call Initiative Urban Futurability in Sao Paulo. So Sao Paulo is a city of 22 million people, more than nearly 7 to 8 million customers in terms of the network utility customer. And Enel in Sao Paulo has been digitalizing the grid. And when I mean digitalizing and twinning the grid, they've been reconstructing a 3D model of their overhead line and the underground line, with the objective of helping asset maintenance, helping to predict where actually you have some constraint on your network and also constraint on your cable, so doing also vegetation management. So they've been really training with a number of LiDAR system, AI, combined with video analytics, really about redetecting all the assets that they have, including 5,000 sensors which are giving them extra information on what is the state of my assets, what is temperature, what is the state of the assets, what is the voltage that I have. So combining really these twins, this 3D model of their network together with IoT devices and 5,000 sensors to give you a better understanding of how the network is operating, how can I do better maintenance, and how can I also collaborate with other stakeholders. Because the second thing that Enel X has been doing is basically create a really centralized platform of their twin, but also opening it to different participants. And you see here, participant can be for traffic management, so for the city, and also working with a telecommunication company, which also have a number of assets in the street, offering them actually all those set of data that they are actually collecting, digitizing, and creating a number of twins. So when we talk about energy transition, about making the grid smarter, and about actually new technology and digital technology, analytics is definitely an important one. Twins is also one, but you will see a lot of other technology coming from obviously your robotics. You will see also a lot of video analytics, because people talk about analytics as data, but it's also video analytics, as you can see here. So all those technology are starting to augment your system, being your ADMS system, being obviously your substation automation, being your volt-var optimization, and being all the assets which are on the grid. With this, Gary, I'll hand over to you.
Thank you, Eric. Okay, so thank you, Eric, for this insightful presentation. So our next speaker is Martin Horst. So Martin is actually leading the Nokia network for energy in Asia Pacific, supporting the requirements of utilities, oil and gas, and mining companies brought by digitalization, distributed generation, and smart cities. So Martin is working with leading energy companies in Australia, ASEAN, China, and India. He has been driving the shift to new business models since 2006 with the first project of Smart Grid. He has a particular interest in leveraging analytics, VPP, AMI, microgrid, renewables, and storage for distribution of optimization. He has about 20 years of experience in utilities and energy industry and has led many strategy and transformation projects for the clients. So prior to joining Nokia, Martin is actually leading the essential smart grid services for Asia Pacific, working with customers in Singapore, Malaysia, Thailand, and Australia on asset management, smart grid, and AMI roadmaps and new business model. So his presentation topic for the day is next generation communication and IoT. So without further ado, I'll hand it over to Martin.
Thank you very much, Gary. Thank you, and it's a pleasure being here. I've followed the distinguished speaker Eric, and we have got a giant, very strong team. So I'll focus on what I can contribute as Nokia, which is more from the infrastructure layer. But coming from Accenture, I bring how the infrastructure can support the new changed environment. Gary already mentioned the chaos that's been happening. Being German, I'm personally affected by that. Near my parents' home, some people died in the floods. Something, if you had told me that in Germany a flood will kill a person in one of my neighboring towns, it's impossible. It rains in Germany. Yes, the weather is pretty ugly, but people getting killed by floods is unbelievable. We also have the dubious pleasure of being one of the first countries to try to switch everything to renewables. We've turned off the nukes, and the result is, as you can see here in the middle, famine and flood. One moment we have got oversupply in power system, the next moment we are short. Luckily, we are connected to the rest of Europe, which have stopped us from taking down the European grid so far. But this is definitely informed my decision when I look at examples. Germany now just allocated 450 hertz as a frequency to help manage the renewables. So if there's one part that Eric mentioned with digitalization and automation, we need to have communication to connect all those devices. How can we communicate? We have strong proven technology on the backbone, IP MPLS, but then when we reach the edge, we've got millions of devices. We foresee that in the future we have 2 to 3 devices per home that need to be controlled remotely, and that's basically impossible if you try to get fiber to every device. But with private LTE, we are seeing good traction here. This which allows mission critical communication with low latency. The examples that I'd like to share, this is, as you can see, Hong Kong, very demanding utility, almost on par in reliability, extremely stringent end-to-end latency under 4 milliseconds, as well as delay asymmetry for tailor protection. So IP MPLS is a proven technology to handle these. Then coming to a place closer to Singapore in requirements, California, this is in San Diego. The renewable targets have already been overachieved by 2020, and they were wondering, so how can we manage all that stuff? How can we manage all the batteries that Eric was talking about? And the customers there, even the Sempra people told me, you can produce 70% of your own power and just the grid basically as backup. Also, green communities are going everywhere. EV charging was proliferating. How could they support that? They realized they need to have a strong backbone system, so they went with IP MPLS. But then they extended it to a private network to reach all those endpoints. This has been one of the reasons why Sempra has not been affected by the fires, but also why they've been able to have more green communities and become DSO, as Eric mentioned before. So now that we have got communication, by itself it is nice to have, but what really matters, and I agree with Eric on that one, is the analytics. This is a wind farm, and it's really hard to connect all the wind towers across the hilly area. They're using private networks to do that. Now we are offering networks as a service, very powerful, and working with OSI software, I believe many of you are familiar with. Another example, I agree with regarding video. This is New York Power Authority. They are letting drones fly autonomously along the transmission lines, doing the video analytics. Again, a very good example of using more data, more analytics. Lastly, we talked about the new distributed generation. This is an Israeli company with a single piston engine, but that has over 50 sensors along this tiny 10-kilogram block. Because thanks to those sensors, we have got now so much data that it's almost like a jet engine from GE. So we are using Nokia's IoT platform to collect the data and analyze the data, enabling higher reliability on the network with having lower cost. I see these kind of solutions, particularly in Southeast Asia for rural parts, but also in Singapore. If you have solar and battery, we need some sort of backup for some percent of the time. In conclusion, I would like to share Bell Labs architecture. Bell Labs, the people that invented the telephone in the US, they realized the industry is changing, but they figured out we need a secure environment that's flexible enough to adapt to those changes. We need to collect all the devices at the edge, have probably some sort of edge compute with edge cloud, and then layers that allow us to deploy new applications without having to rewrite everything. Typically, utilities for smart metering deploy IFMesh, for SCADA deploy dealer protection. By having those vertical silos, some utilities have up to 17 different communication systems, including Tetra. This is not sustainable in this world of fast change, and this is a suggestion from Bell Labs to look at when we start deploying new communications architectures. With that, let me hand back to you, Gary, and thank you very much.
Thank you, Martin. So our next speaker is Jen Emresh from Black & Veatch. So Jen is actually an electrical engineer and project management lead for Global Transmission Asia in Black & Veatch. His responsibilities include supporting business capture and project execution for electrical transmission projects. So these project services are consultancy services, owners and details engineering, EPC for any transmission asset in Asia. So his experience includes about 30+ years in electrical transmission and distribution, managing high voltage substation engineering, project management, and proposal management. So his topic of the day is emerging trends in digital substations. So over to you, Jen.
Thank you, Gary. Let me share my screen. Yep. So, and good afternoon to all, and sincere thanks to SP Power Grid and EMA and organizers to provide this opportunity to participate as a panelist for this event. So digitalization we know that it's taking over all areas of our daily life, be it phones, vehicles, home appliances, even shopping, schooling nowadays in COVID times. So it's almost everywhere. And why would an electrical transmission industry also left untouched? I think we have already started moving in that direction of digitalization in our industry also. So asking a question, what is digitalization? So in the context of a digital substation, this means replacing the analog signaling infrastructure that we have currently by the digital networks and the smart devices that are going to be connected in that digital network, which essentially means the IEC 61850 capable relays, the merging units, all connected in a digital network in a substation. So further in that digital network, also connecting the asset health monitoring equipment for all the major substation equipments like breakers, transformers, bushings, etc. So this in a whole is what is going to be in future a complete digital substation. At present, almost all utilities have already adopted the substation automation system based on transferring towards IEC 61850, and a full digital substation will mean graduating several steps further to become a full digital substation here. So, so the next question comes, why digitalization? So what really are the enablers and advantages for a digitalization or a digital substation? So it really gives a expanded access to data. So that increases the data availability and also the throughput, leading to a new analytics use cases, which increases definitely. If we have more use cases to study, we can increase the reliability and the resiliency of the substation and in turn the grid, and also the asset management capabilities. On the physical front, it eliminates significant control cable installment, supply in favor of digital networks. So control cable being replaced by the digital networks, optical fiber and network equipment. And it provides opportunity for simplification and templatization of design also. Like, for example, if you're using a merging unit for the current transformers, definitely you don't need to have so many different requirements and parameters to be followed. So that really simplifies and templatizes the design aspects also. It also, in the physical aspect, there is a smaller control house footprint because of the reduction in the equipment that are required in the substation for physically. There's one more study that our US teams and US experts have done, that it increases the immunity to EMP, which is the electromagnetic pulse, which generally it generates and basically damages the electronic devices and the control devices in a control house. And what really happens is that in a digital substation, the optical isolation is happening for the field signals and also the control devices in the substation. And so this protection is implemented here when we apply the digital substation configuration. The safety aspects of the construction. So what really happens is the transmission infrastructure construction, it migrates to a controlled or a factory environment. And what really it happens is it's a modularized construction deployment with fiber optic cabling using a plug and play connection. So that's what we would be heading to when we are going to adopt the full digital substation design. However, whenever we have a new thing coming, or when we are trying to change, and that change is not very small, it's quite a big change for all the asset owners. So there would be some risks and challenges. And being a part of a digital network, so a digital substation will be prone to cyber attacks. And so a cyber security will be required for appropriate mitigation measures. Another aspect that comes here, another challenge is on the competency and capability of the field technician requirements. So with the factory and modular construction increasing, the skill set of a field technician would more require towards an IT skill set rather than an electrician skill set. And also the knowledge for those technicians, more and more on the communication technologies also, in addition to the normal power knowledge for the troubleshooting purposes. However, one more challenge remains that for this kind of a design, the knowledge base or the reference data is still very limited for an informed, reliable design. Which is required because we are integrating both the power technology and the communication technology together here. And of course, we all know that in the IT industry, the hardware evolution cycle is much faster than the life of a substation generally that we consider, around 20-25 years. But a hardware evolution would be much lesser than that, maybe in 10 years or so. So this is another challenge that needs to be overcome when we are going to adopt this technology. So where is the future leading us? So what are the future trends that are going to come up with this adopting of this technology? So it's like On the protection application front, it's virtualizing the protection application, which at present, these are residing in, say, 50 to 100 relays in a substation, which are all purpose built for specific applications. And the future may be going to a hardware consolidation of all these into a commercially available server platforms. And so what it really means is a big disruption in this protection application if we actually realize this in future. And further, what advantages that it gives is it lowers the patch management or the firmware updates and the asset tracking and maintenance. Another thing is that the owner would be leveraging large data sets that are created from the digital network, which contains several sensors and other devices for the inputs, and it helps develop predictive algorithms which can be developed using machine learning for the predictive analytics part, and it will be easier and more tends toward predicting the failures and facilitate condition-based maintenance rather than scheduled maintenance, which we already have started working in different areas. Different owners have started working on that. And this would also open doors for digital twin concept, which Eric just now shared in his presentation also. So it basically building a knowledge database of the equipment and also associated digital twin to increase the visibility of the equipment parameters and modeling of the equipment operation in the for the substation. And in the end, going much further into the future. So this can be further extended to a augmented reality, where we would be overlaying a substation asset information on a 3D model, which can be leveraged to support improved maintenance performance and maybe digital maintenance. And I think Gary asked me a question during our earlier that what is the concept of a digital crew? I think this would be a concept of a digital crew that can be used in future with the concept of digital substation for the operation and maintenance. So over to you, Gary. I think that was all for my presentation. Thank you.
Thank you, Jen. So let me take over this presentation here. So last but not least, our last speaker is Nugroho Prananto Utomo, also known as Prana. So he's a senior consultant in DMV Singapore. He has more than 10 years of experience in design and implementation of control systems. He is well versed with control system architecture, utility data management, power system engineering, communication protocols, and cybersecurity. He is also involved in several cybersecurity penetration tests and review for utilities and OEMs in the region, specializing in OT security and critical infrastructure protection. He has a master and bachelor degree in power engineering. He is also a certified ethical hacker and global industrial cybersecurity professional. So his topic for the day is control system architecture from flat network to zero trust. So over to you, Prana.
Okay, Gary. So let me share my screen. Okay, so yeah, thank you for having me as a panelist for this discussion. So I think we see from the other panelists that explain that now its control system is moving forward into IoT, to digital twins. But then I just want to brief you what is the history of the control system. Originally, control system was just simple system that actually get data from the RTU, PLC, ID, and come to the control center, whereas you can monitor the network. So this thing is already moved forward, like what other panelists explained. In this drawing, I just want to show how is the future distribution management system, or we call it ADMS, become more connected to the other system, whether it can be connected to the asset management system, can be connected to a field crew, meter system, or even the analytics. So we can see that this one is control system is growing and more complex system. Just to just to give like help the utilities to have the streamlined business process. But then the question raised is like how we secure this kind of network. We start with the, we try to segregate the network based on the security level. Then it start with the Pudu reference architecture, and now start is standardized with the IEC 62443 zones and conduit. So this drawing is come from the Homeland Security, like the house suggestion, like the ICS looks like. So you can see all these different by secret layer with the all conduit necessary. But then in order to make sure that this secure, then we start to develop the new advanced conduit like next generation firewall, which is like application firewall, which include the packet inspection and control. Even in more secure system, they already implement unidirectional gateway. But although we can secure this network, but there is a challenge in this kind of architecture. First one, we see that increased number of remote connection. Like for example, like ADMS, the field crew need to connect and access using public internet. Like just now, I think Martin explained about the private network and private 4G. But this one also still, you still like somehow trust the other system to connect, right? So also the IoT penetration, which is you cannot make all connected as with fiber, for example. So this thing is like a challenge with this like zones. And the second thing is regarding when the control system now is become connect to the all IT based like GIS, MDMS, all the other system, make the design of this advance is more complex. But still with the layer architecture, basically you create like hard and crunchy on outside, but soft and chewy inside. So it means that once people can inside, then it can be moving lateral very easy because we only protect the layer. So one of the architecture that now is starting to become growing trend is the zero trust. So this one, especially in US now in May 2021, there is an executive order from the White House mentioned that now is to see like whether how the US can implement zero trust architecture. So basically the zero trust is like a security model, design principles, and coordinated cyber security management system that acknowledge basically the threat is not exist in the outside, but also exists inside of the network boundaries. So according to this, like based on NIST special publication 800 to 2007, 207, that this zero trust have following tenet. So the first one, like the all data and source computing considered resource. So now with data computing power is resource. The communication need to be secure. Doesn't matter when the network location is. Then the access of individual resource need to be granted per session basis. Then the resource of access will be determined on dynamic policy, not a fixed policy. The dynamic policy can include behavior, environmental attributes, including how we can see the identity of the client, application running on it, and even requesting asset. Then the next one, the enterprise shall monitor all the own and other assets, and resource and authentication will be dynamic and will be enforced before the access can be granted. Then the last one, the last tenet is the enterprise will collect all the information as possible just to identify the current state of the asset, network infrastructure, and communication in order to improve the security posture. So from the same special publication from NIST, we can see that this is how the zero trust is working. Like for example, like any subject user or application want to access the resource and the system data, they need to go so-called the policy decision point. And this policy decision point is based on the policy enforcement point. So this policy is a control whether this subject can access the behind the resource. So how this policy enforcement get the access is basically the one of the logical component of zero trust architecture is the policy engine. This policy engine is responsible for ultimate like how the access should be granted. And this policy engine supported by policy administrator that control the access of each subject. So in order to support policy engine, there is a multiple input that need to be gathered by this policy engine. For example, like the CDM system, the continuous diagnostic and mitigation system, industry compliance system, threat intelligence feed, and also network and system activity law, data access policy. If enterprise using the PKI, then the PKI need to be consideration. And also like with the ID management system and the CM system. So how actually it works? So basically when originally like every subject, of course, they will ask the request the access. So first they request the access. Then it's not only we just request and check whether the user able to log in, we need to consider like whether the subject database and history, what is the asset database, what is the resource policy, and even the threat intelligence. Based on the certain algorithm, if everything is perfectly fine, then it will be grant access. So this is like the how the zero trust is designed. So but what is benefit of this having this zero trust? First, we eliminate implicit trust. So basically, we basically don't trust anyone. So that's why zero trust. So we don't have any implicit trust. For example, like if you connect from workstation, it's considered secure. There is no such thing anymore. So what is benefit on having this is basically we improve the scalability of system integration. So the system integration will be more scalable and more easier to be integrated. So and the second one is that we can provide the real-time assessment of determined access. So by provide the real-time assessment, we basically we improve the security and also limit so-called lateral attack. But what is the challenge? Because what we know now is most of the utilities implement perimeter-based architect network. So basically, when during introduction of the zero trust architecture, we need to more additional effort. First, to identify your asset, your subject, data flow, and also workflow. Yeah, I think that's all for me. So back to you, Gary.
Okay. Thank you, Prana. Thank you for this insightful presentation. So I especially like the term that you use, the current security posture. Hard and crispy outside, soft and creamy inside. So I think that we only have about 6 minutes to the end of this technical session. So we have a couple of questions, but I think we can only take one of the question. So maybe I just start with this question. This is also timely with regards to Prana cybersecurity presentation. So the question goes like that: digitalization requires the integration of systems to provide holistic insights for decision support. However, from cybersecurity perspective, the most secure systems is an isolated one, hard and crispy outside. So integration versus isolation. In present or in many utilities, they practice security by isolation. But when we move forward into the digital future, we need more information, things to be integrated as much as possible. So I'd like to get a sensing from all the panelists. What's your view on this? Maybe a quick one, a minute from each of the panelists. What's your view on this question?
Want me to start, Gary?
Yes, Eric, please.
So my view is very simple. It's about integration. We're talking about actually data science, data analytics, about actually creating new ecosystem. I think a lot of the business models are going to change. And if you want to create flexibility on the market, you will need to have much more collaboration, exchange of data. So basically for me, it's a matter of finding the right, I would say, cybersecurity solution. And there are already, when you look at IT-OT convergence, there's already a number, I would say, of cybersecurity model and standard to be followed. So I don't think that actually we shouldn't be, I would say, afraid of the cybersecurity. It's there, we know, we need to take it into consideration, but it shouldn't prevent us from doing the right thing. And the right thing is that integrating data and collaborating with the ecosystem will be a must. So yeah, it's clearly for me integration.
From my side, when I look at, in particular, sensors, the amount of controls we will have in the grid, if you have 12 million devices, like in a mobile network, that Nokia has a little bit experience with, we need to have integrated security. It cannot be just perimeter security. Every device is part of the network. As such, we need to have those mechanisms. If there's somebody inside, like in Ukraine case, if you look at state actors, they will always find ways to get in. They even got into the F-22 program. So if they can hack into those, then
you bet they get into this, but how do we stop them once they start creating danger? Those kind of integrated security tools are necessary, and we can offer them, like as you see in our 5G discussions.
Okay, thank you, Martin. Jen, you have any comment on this?
Yeah, I agree with Martin and Eric that it has to, the system will always be integrated. So the security also will have to be a kind of a solution which is integrated. Maybe something like it's a hard from outside for a certain extent and soft from inside. But even if it's inside, there may be a certain layers of security because different type of dangers may be there at different layers. So I just now saw while moving in the different digital rooms, there was one solution for preventing hacking from in a, I forgot the name. It was a grid resilience kind of a thing. So something like those kind of innovations at different levels, I think would be the answer for that. That is my view.
Okay, Prana?
Yes, I think a simple question will be integration. Of course, like what other panelists mentioned, but also need to consider like what is the risk that authorities are able to take up. Maybe we can promote all the integration, but we need to see what is benefit that gather. For example, like moving to ADMS. I mean, I just example like one ADMS. You can move the ADMS, you integrate with GIS, all IT system. You see the risk will be coming from an IT system, but what is benefit? For example, by doing ADMS, you can handle the outage very fast because you have the analytics platform behind that. You have GIS system to help you to locate the outage. So these things still like we need to consider. So I mean, we need to see risk-based approach, how to see whether we go to integration or isolation. Yeah, that's my view on this, Gary.
Okay. So I think the general view is that integration definitely have a lot of use cases moving forward into the future. We need data. We need data to give us information so that we can actually mitigate or control our network to improve reliability, to maintain or improve reliability. So, but this has to be done in a risk-based approach. So having a proper risk management to assess what the cybersecurity exposure and what is the appropriate controls to be deployed. So, so I think that would be the key, I think, to the future in terms of digitalization when we are talking about OT and IT convergence in this case. So I think that we are running out of time. It's 5 p.m. now. I hope everyone enjoyed this short 1 hour workshop. It's a pity, just 1 hour. We have a lot of expertise and experience in this workshop. So I'd like to take this opportunity to thank the speakers for your commitment and your time to prepare the slides and do this presentation. So with that, I think I would like to invite everyone back to the main webinar, and we will have this the startup webinar coming up shortly. So thank you, everyone.
Thank you.
Okay, thank you.
Thank you.
Thank you.
So is Martin back? let me check with. Oh yeah, Martin, you're back.
Sorry, Dave. I thought you asked everyone to come back. I thought we didn't take a picture. Sorry, I've got another call, but then let's take a picture.
No worries, no worries, no worries. So I don't know. Jason, are you still there, Jason?
Hi, Gary.
We can help to take.
Okay, we can help to take the photo. Right.
I think I better slide it.
Okay.
Okay. We'll count to 3 now. We'll take a photo for you guys. Okay, 1, 2, 3. One more, 1, 2, 3. Very nice. Thanks everyone for joining us for the webinar.
Yeah,
Thanks, Eric. Thanks, Eric, for picking me.
Sure. Okay, we can do one more.
We can do one more.
Yeah. Okay, with the hearts, I guess. 1, 2, 3. Okay. Need the hearts. Okay, one more. 1, 2, 3.
Okay.
Okay, hold on. One more time. Hold on. Okay, 1, 2, 3. Nice. Okay, thanks everybody.
Okay, Gary, we will follow you.
Thanks, everybody. Thanks, Eric.
Thank you, everyone.
Thank you.
Thank you, Gary.
Bye.
Bye.